Hi, everybody. How are y'all this morning?
Doing good.
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 How about you?
Pretty good.
I'm sleepy. Yes. I've woken up. I woke up like I normally have been waking up at like 2 and I woke up at 8 this morning.
Oh, wow.
And it did not sound. It was not the move.
Wow. Oh, that's amazing. All right. So I went ahead and put the video for 8.4 and the notes for 8.4 up on Canvas for you. And what I'm going to be doing between now and this weekend will be switching all of my videos over to YouTube for you. And we should not have the problems that we've been encountering with Stream. I chose Stream mainly because that way all of the videos could be held in the cloud and it wouldn't clog up our Zoom very much. But after talking to another colleague, I think I've decided to go and change them over to YouTube now. And so what I'll do is as I move them over to YouTube, then I'll bring the link to YouTube video over to the Canvas for you. And I'm trying to think, last night I ran through all the videos. Let's see, and there's probably about 5, I believe. So actually 10, because 8.2, I had to splice it up into several little sections. So there's about like 10 videos. And these Zoom meetings that we've been having, if they held any good content to them, I went ahead and saved those too so that I can put them on Canvas for you. Okay. Mm-hmm. I'm looking at your calendar, and again, this starting on Friday, the school would have been closed anyway, so we would not have had classes. And so that's why I have pushed out your due date for the lab number 2, which I've posted now in Canvas for you. That'll be due on the 14th, and your quiz will also be due on the 14th. The quiz is in my math lab, and the lab is actually in Canvas. On the lab and on the lab for sure, it will require you to do all of your work. If you can get a printed copy of the lab, download it and print it, that's great. If you can't, that's okay. Just if you'll number the problem that you're working on your notebook paper, and then if you can upload that for me. Okay, either way, I need uploaded work for the lab. On the quiz, being on my math lab, you can opt in to upload your work if you'd like to. I use that for partial credit, and that way if you miss a problem, I can definitely go in there and see what I can do to help out that grade. Okay. Mm-hmm.
Is the quiz timed?
The quiz is not timed, but there is a due time for it.
Okay, sounds good.
The only thing that's actually going to be timed will be your, I say that, I didn't even look to see if it has a time on it. I know your lab is not timed, of course, because you can download work on it. I can't remember. I'll have to go back and look at the quiz to see if it's actually, I can't remember if I put a time on it or not. But when it's submitted, you need to upload your work if you're going to within the next 20 minutes after the quiz. No, that's a good question. It's been a while since we've taken a quiz on my math lab. That's the one thing I didn't look at. I changed the date on it, but then that was it.
Let me see.
So there is one discrepancy on the revised syllabus. The revised syllabus said that the quiz would be due on the 15th. It's actually the 14th. So we're running live with the calendar in Canvas and also the assignments in Canvas. Okay. This lab will cover sections 8, 1, 2, and 3. And then the quiz will cover all 4 sections of chapter 8. And then I already have a problem for you that I'll call a bonus problem on the test. I believe we're testing on the 20th is when it will, looks like it'll open on the 20th and close on the 22nd. So that following week. And that quiz will cover that test will be timed like last time. It will also have material from chapter 8 and 12. Okay, that'll be our new chapter that I work on between now and the next time I see you. Okay.
Mm-hmm.
Do you have any questions from the first 3 sections of chapter 8 so far?
I think I do have one.
Okay.
How do you figure out if there's more than one triangle? Is it like if the angles don't add up to be a previous angle you already discovered? Is that how you do it, or?
Well, there's several different ways. Let me turn this video off so that you don't have to watch my. There we go. And let me pull up a situation. If I can find our stuff real quick. Okay, so in 8.2, oops, that's 8.1. Okay, so let me go back and find 8.2. But in 8.2, that's where we want to look at some of those problems there. And I just renamed all these, so that's the area 1. There's your lab. That looks like him. Okay. In 8.2, we're looking at law of signs here. And basically what it says is that sometimes when someone hands you parts to a triangle, for example, these parts could be used in different ways. And what I mean by that is sometimes you're given whoops, let me get a pen. You're given a leg or a side of a triangle. You're given another side of a triangle, and then you're told that you have an angle in here that measures so many degrees. A lot of times this will end up being where, let's say that you and I have how about a 30-degree angle in here? Okay. And so what happens is as you start to try to put this triangle together, the 30-degree angle may actually end up looking like a true 30-degree, like we have here. One side could come here, another side could come here, and then the mystery side we're looking for would be right there. Okay. However, you could also have had a triangle that instead of looking at the 30-degree angle, I'll mark him here, there's that 30-degree angle. We're going to look to see if possibly the lengths of these sides that were given to us could have also have housed an obtuse angle, which is its supplement. Okay. So in the notes, when you go back and look, let's look at the example that actually does it for us. And let me clean out this stuff here. Okay. And I believe it's actually this last example before we get into the actual applications. And so here, we've been given an angle that's 15 degrees. We've been given a side that's 6 degrees that's across from it. And here we have an angle, a side of 10. And just from the given right there, when you go to try to put this triangle together, you have an angle of 15. So this will be my angle C. Across from him, I have a value of 6. And another one of these legs here must be the value for A. So if I call this angle A, then this would have to be 10. And here's angle B with side B. Okay. So what we try to find out is as we go through here, if you and I should be able to find angle A, and we should be able to find angle B. That should not be a big deal for us. We should be able to do that. Now, the problem is that as we find one of the angles here, and remember we talked about this, I think on Monday, that the law of sines is the best to use for the smallest angle. And if you want to find the largest angle, you'd use the law of cosines. Okay, so when we go in here and we start to find one of the first angles that we have here, we're either going to find angle A or angle B. The three things that cannot change are the three things that gave us right here. So when we have triangle number 1, we already have 15-degree angle. We have a side C of 6. And we also have a side of 10. When we test for triangle 2, we still have angle C is 15, side C is 6, side A is 10. Nothing can change from the given. But what could have happened instead was we might be able to take these measurements here, and instead of us looking at a triangle that's an acute triangle possibly, we might look at it as if here's the side 6, here's the side 10. If we did something like this, okay, then all of a sudden this angle that's between these two sides happens to be greater than what we had in the first triangle. So here's basically what needs to be done, just shorthand here. The first thing we need to do is actually determine which angle we want to go and solve for. So we want to solve for A or B.
A.
Okay. If we go solve for A is going to be our largest one, right?
Mm-hmm.
Okay. So, oh, you know what? At this time, I tell you what, let's go solve, if you don't mind, let's go solve for, yeah, well, let's just solve for A and see what happens. Okay. So if we go and solve for angle A, then we know that we have the sine of 15 degrees is to 6, as the sine of angle A would be to 10. And then as we go through the arithmetic, we'll find out that we have 10 sine 15. And if you go in there now and calculate what the value of A will be. So this is 10 times the sine of 15 over 6. Take its inverse sine. So if you do that, I forget what the value is, so let me run this real quick. 10 sine 15, and then divided by 6. And if we go to 1 decimal place, we get a 25.6 degree angle here. Okay. All right, so let me kind of mark through this problem right here so we have a lot more room. So what he's telling me is that in triangle number 1, if you assume the given, oops, that's going to be C. And A is 10. We just found out that angle A is 25.6 degrees. Now what that tells me is that I'm looking at a triangle here in such a way. Now I want to see if a second triangle could possibly have been formed also. A lot of times I'll put subscripts on my angles for the second triangle so everybody knows it's the second one we're looking at. But angle A this time is not going to be 25.6 degrees. What we're going to say is that if we were looking at one of the sides, in this case, and we saw that we had an angle A of 25.6 degrees, the reason why I've drawn out this horizontal here is because 25.6 degrees is supplementary to this angle that's right here. This would be A2. And so if I were to take 180 degrees minus 25.6 degrees, I would now check to see whether or not I will have enough room to build a second designed triangle. This one here ends up being, what, one something. How about 154.4? Is that right?
Let me pull my calculator real quick.
I think that's right.
Yeah, 154.4.
So the question now that we pretty much have to always prepare for 2, and it'll tell us if we don't have 2 for sure. Right here, this is how I'm going to tell if there's a second triangle. I'm going to go in there and say, okay, in a second triangle, I would not only have the angle A and the angle C, but I would also have the second version of angle B. Regardless, it has to be 180 degrees. Is there enough room for us to sneak in a third angle? So if we have 154.4 and we have the 15 that was given to us, is there enough room for us to get the third angle? It looks like there is. If you were to take 15 away from all of that, then I think you'll end up with what, 10.6, is that right?
Yeah.
All right. So in the first triangle, I didn't finish it, but at this stage right here, the minute you find one of the missing angles in your triangle, the next thing you want to do immediately is, can there be a second triangle? So you want to take that angle measure away from 180. Sometimes this angle will be acute, like ours is this time, which will throw the second version of A into an obtuse angle. Sometimes it'll be obtuse at the very beginning, and then it'll throw you an acute, okay? What we always have to ask ourselves, and this is always the question that we're trying to answer, is does a second triangle even exist out there or not? And so in this case, you and I could have had our 15-degree angle, might have been, let's say in the original triangle, he might have been down here somewhere, 15 was. And now that we have witnessed that there is enough room to make angle A obtuse instead, that 15-degree angle might be somewhere like here now in the second triangle. So you're always trying to be prepared to see if you have more than one, okay? I don't know if everybody's gone through the other 2 examples or not, but Jared, do you mind if I go back to the example right before this one?
Oh, you're fine. Go ahead.
Let me run back here real quick. And in the second example here, in the second example, we have a situation, and a lot of times you won't know. You won't know if you've got one triangle or not. You can't tell sometimes. This one here says, I'm going to go ahead and start off as assuming that I have 2 triangles until he tells me I don't. So in triangle number 1, angle B was given, side B and side A. So just by looking at the given right there, we've got a pair of information. So that means I can set up the law of sines and find out. I said 3 and I wrote A. Here we go. We can set up a law of sines so we can find angle A. So if we come in here and we say, okay, the sine of 35 is to 5, as the sine of missing angle A is to 3. It won't always be angle A that's missing. It just happened that way in both of these examples. Now when I go in there and I solve for A, I'll have the sine of A is equal to 3 times the sine of 35 over 5. And now you'll take the inverse sine of that. So my point of this is trying to get you to see what happens. How do I know if there will be a second one or not? So at this stage right here, the minute we find out what the inverse sine of 3 sine 35 divided by 5 is, I'm getting about a 20.1 degree angle here. Before I go and solve anything else on that triangle, I'm going to come over here and say, okay, whoops, in triangle 2, the given for angle B was 35. The side for B is 5. I can't change any of these values because that's the given. But what I can do is I can go research to see if a second triangle will exist. Our technique that we're using to see if that triangle exists or not is to take the second angle of A will be formed then by 180 minus 20.1 degrees. If this triangle exists, then the second value of A here has to be, what is that, 159.9 degrees. That's what it has to be.
I have a question.
Mm-hmm.
How do you know that you're looking for the smallest angle to begin with?
Well, it all depends on what the given is. And in our case, I didn't really have a chance of looking for the smallest angle or the largest angle in my case, simply because I have to work with what they give me. And so when they give me a situation here where I have two sides and a non-inclusive angle, this is the time when a second triangle might be formed. And so I literally had to say, okay, do I have a pair of information? Yeah, the B's. So that's why I set up this fraction right here. And then A was known. So that's how I knew to go in search of angle A. It just happens to be the smallest angle.
Okay, gotcha.
Okay. So now the question is, how do I know if this second triangle is really going to be out there or not? Let me come up down here at the bottom. Sorry about that. But if I have a second triangle, then A, the second version of A, the B, the mystery C angle out there that I'm still going to be looking for later has to equal to 180 if there is a second triangle. And I think you'll see if you start adding up 159.9 to the 35 that was given, do you have any room for angle C in this triangle?
No.
No, because 159.9 plus 35 more degrees, this total right here is already 194.9. Plus you're supposed to add another angle, and it's only supposed to add up to 180 degrees within. This means that no second triangle exists. There's no way. You don't have enough room for it. And so what happens whenever they move these two pieces, 3 and 5, the lengths of 3 and 5, they couldn't shut it up. Like here's 3. Let's say here's 5. Well, let's see. My picture would not be correct in that case. Hold on. If you had the picture that looked like this was 5 and this was 3, let's say we put them this way, right? So we have that 159.9 degree angle here. There's no way it's gonna, because this side here needs to be super large across from the super large angle. And so this side's gonna shut down after 5 units. This side's gonna shut down after 3 units. And you're needing to hook it to one of these ends of your legs. And it's not, you don't have enough room. You can't close it because this angle is so big right here. So that's what they're asking you to do. You're going in there and you're, with the given information, can you make a second triangle? In fact, can you even make a first triangle sometimes? If you looked at the first example, the mathematics, I mean, he literally tells you that something's wrong. You can, if you've done this one also, you're given a pair of information here. This is a side angle problem again. My suggestion to you always has been, why not go in there and at least get a drawing of what you think it might look like. There's A with 50 degrees. So 5 would be over here. And 8 could be here if he wanted to be. This is angle B then. Try to find angle B and see what happens. And the mathematics here will tell you straight up that it's not going to work. Sine of 50 is to 5, as the sine of B is to 8. And when you go in there and you do your arithmetic, this will be the sine of B is equal to 8 sine 50 divided by 5. And if you'll just take this value right here and look at it, just that value, forget about the sign right now, the inverse sign. So just take 8 sine 50 and divide that by the number 5. And what he's telling you then is that the sine of an angle could be 1.2256 blah, blah, blah. And what do you know about this statement right there? Can the sine of an angle be 1.22?
No, I think it has to be like under 1, right?
Yeah. The sine graph that we learned about, his range is always from -1 to +1 inclusively. So what happens is a lot of times we won't like take a second to look at what this number actually is. We're just kind of in the game plan of let's go all out for B. And when you go all out for B, that's fine. But you need to realize that you're about to take the inverse sine of this value. And when you do that on your calculator, it'll literally tell you, You take the inverse sine of that value that we just came up with, and he'll give you an error message. He says, quit. The value you entered is not allowed in the function. So if we don't recognize what the error message is telling us, then we've got to figure out why it is that this sine of B will not even exist. And so in this case, the value, the angle measure B does not exist. And so if you can't find the angle that goes across from side 8, then there's no triangle at all. So the no triangle case is pretty easy. It's going to step right up into the calculator and tell you, uh-oh, you have a problem. When you have just one triangle or two triangles, you have to be ready, okay, to determine whether or not a second triangle will actually exist. To kind of make it cut and dry, once you set up an SSA triangle, you'll always be given a pair of information. That's what makes it an SSA. And so when you use your law of sines, once you find that angle's value, immediately see what the angle would have been in the other triangle, triangle number 2, and then test whether or not you actually have any room for a third angle to come on board, okay? If there's not any room here, then that means there's not a second triangle. Does that help with the step-by-step?
Yes.
Yes.
If you read in the textbook, they've got a wonderful kind of a way to describe it also. What's happening is that if the height or the altitude of the triangle ends up being greater than your smallest side, then you don't have a triangle. If it's less than your smallest side, then you will have one triangle. And then if it's greater than, I think it's A and B, then you'll have 2 triangles. So you can go in there and read about that. My problem with that, sharing it with you, is the fact that it's you have to go off kind of like on the side to figure out what the altitude of the triangle is before you can come back in and decide if there's going to be 1, 2, or no triangles. So this is a much simpler procedure. And it literally, you're saying, okay, if I have these 2 pieces of, let's say, string or something, and I want to try to make a triangle, okay, well, I can put them this way, or I wonder if I could put them this way. So there's 2 different ways that you could actually put those 2 ends of strings together. One time it'll form the acute angle, and one time it'll form the obtuse angle. And you're just trying to see if there's a possibility that you could have made 2 different triangle shapes. That's all you're looking for. Okay, and since we know that when you measure an angle, its supplement, right? Its supplement is always going to be 180 degrees sum. That's what supplement means. Then that's why we use the 180 here. This has nothing to do with the triangle. When you go to look for the second angle, this is a supplementary situation. The 180 degrees in a triangle is right here. Okay, when you're adding up three angles together. So it is, I say be prepared for 2. If your calculator doesn't say that it doesn't exist, then you better be ready for 2 triangles. And either you'll prove that there's not a second one, or you'll prove that there is one, and you'll need to find all the pieces.
Sorry, sir?
Did you get those rocks done?
Yeah.
Okay.
Yes, sir.
So, just to recap,
They do, yeah.
if the given provides you with one angle, then you have to go solve for the second triangle and see if there is a second triangle. If it has 2 angles, then it's only one triangle. Right?
Yeah.
Yeah, because basically this ambiguous case right here only happens when you're given a side angle situation. And so, like I said, to me, it's easier if, I mean, regardless of what you think it might look like, that's not the issue. But if you'll just diagram a triangle for yourself, and we've got this angle right here, we've got A, that's what was given to us, and we were given 5, okay, and then we were given 8. So just look at the triangle in blue there. We've got an angle, we've got a side, and we've got a side. So this is side angle. So because of the given information, we know that we're in an ambiguous case. We'll either have no triangle, 1 triangle, or 2. If you go back to just look at the example, let's see if I can get there. If you go back before that and look at it, you'll see that if you have side angle, so that means if you have a triangle and you're given a side and 2 angles that do not squeeze that side in between them, or if you're given an angle side, or angle side angle, squeeze the side between the 2 angles. If it's one of those 2 cases, it's straightforward. Okay, there's only going to be 1 triangle. If it's SAA or ASA, so you want to look at what that looks like. SAA, same thing up yonder, a side. It could be this angle and this angle, okay, because that side's not included between them. So in both of these cases here, this is what they are referring to as case number 1. And in both of these cases here, no matter if it's SAA or ASA, you're going to have 1 triangle, if possible. Okay, there's no reason, there's no way you could have 2, because the only way this angle right here could have been formed to be 85 degrees is if this side and this side had already been placed. Does that make sense?
Yes. Makes sense.
If you don't place them, I mean, they could go something like that and have a much bigger angle. So if you're saying I have an 85 degree angle, then that means the initial side and the terminating side are known. Then you move down to the next angle, which happens to be on the next line for you. Well, how do you make this angle be sure that it's 25 degrees? Well, you've got to make sure this is placed, and oh, this was already placed. So check it out. When you know 2 angles and a non-inclusive side, y'all, you know the triangle. You know every part of it. It's right there. Whereas what we were working with, if you're given side angle, okay, where the angle is not included, then I can come in here and I can put a side here. I can put a side here because the angle is up here somewhere. Okay, there's my angle. All right, well, you don't know how big this thing's going to be. You could have also done this. Why not put the 2 sides like that? Okay, and then your angle would have been formed somewhere over here. So because of the given information, that's what decides whether or not you're going to have 1 triangle or the ambiguous case where you have 0, 1, or 2.
So, let's see. Is there only two triangles?
Oh.
One is
What in the
SSA.
Lord?
Somebody's
on.
audio is spazzing.
What is that?
I don't know. I was like,
You sound like Megatron.
All right.
too funny. Okay, you want to try again?
So,
Nope. That's not. You want to type it to me in your chat? That might be easier. Maybe, maybe not. There we go. Okay. So is there only two triangles when there is SSA, or is it possible whenever it is SAS? Okay. If you're given SAS, that means you have an included angle. And that is actually a case for the law of cosines. So SAS is not something that you and I really want to have if we're working with law signs, okay? Because SAS, let's see, he's going to look like, let's see, if you have SAS, then you're going to have in the triangle, you'd have a side, an angle, and a side. So in this case here, there's no way to use the law of sines because you see how you don't have a pair. You don't have a pair of information at all. So the SAS triangle is set up to go and use the law of cosines. And with the law of cosines, you don't have an ambiguous case. Let me see if I can make this so that you understand. In the law of sines, think about what you know about sine, okay? Here's the XY plane. And we know that the sine in the first quadrant is positive, don't we? And in the second quadrant, what is sine's sign? Is it positive or negative? In the second quadrant? Should be positive, right? Thank you. Thank you, Brady. And so what happens then is if you and I in the SSA situation, if you and I are given an angle, let's say that was 25 degrees here, okay, its sine is still positive. If you and I look at the angle, let me change into a different color here. If you and I look at the angle's supplement right here, the sine is still positive. When you go to cosines, that's not true, okay? So the law of cosines doesn't give you an ambiguous case because if cosine is going to be positive, then it's going to be in first quadrant. If the cosine turns out to be negative, that means that you and I would have been in the second quadrant. Cosine happens to be one of those even functions, remember? He's an even function. And so what that told us is that, like, if you end up with the cosine of, who knows, let's say you ended up with a negative 30-degree angle for some reason, that is the same thing as the cosine of 30 degrees. So it deals with the fact that in the first and second quadrant, since sine is the same value, it could be ambiguous, meaning I don't know if the sine value is indicating I'm in quadrant 1 or if I'm in quadrant 2. So that's why I have to check to see if there's a chance that I might have one, none, or even two different triangles. Does that kind of help?
Mm-hmm.
We don't really spend a lot of time on odd and even functions, even though, you know, we mention them to you. We do have identities for them. But like I said, cosine, because he's even, you're going to get the same value regardless if cosine is negative. Cosine is of a negative angle or a positive angle. So there's no ambiguity there at all. But in sine, you bet there is. I have no idea if I'm in first quadrant or second quadrant when I terminated. Okay. What else? When you get into the applications, there's no ambiguity, okay? Well, let me rephrase that. I'm not going to give you an ambiguous case in an application. Question number 8 on 8.4. Okay.
I have the same question as Brady.
Okay. Let me get us back over to where I need to be then. And I know some people probably haven't had the chance to look this guy up yet. I was trying to find my notes that I actually posted. There's my empty ones, and come on, here he is. Okay. All right, so on problem number 8, can someone, I'm not on my math lab over here. Can someone kind of give me an idea of what that thing looks like?
I have it pulled up. It says consult the
Sweet.
figure to the right, which shows a circle of radius r with center at O. Find the area of K of the shaded region as a function of the central angle theta.
Boy, I'm going to wish I had pulled that up. Okay, so we have a circle.
Uh-huh.
It has a radius of r.
Yes, ma'am.
Okay. Now we're supposed to, where is this quote shaded area?
It's a triangle. I mean, it's,
Okay.
but with the thing obviously rounded to the edge of the circle. So
Okay.
horizontally.
All right, I'll tell you what. Let me,
Maybe someone could share their screen for a second while you write it down.
Cool. Let me do it.
I just
I won't let
asked
me.
my instructor on my math lab.
I can get up there real quick. It won't take about a second.
Yeah, it says here that the host disabled participant
Yeah.
screen sharing.
I had to enable it at the very beginning, and I totally forgot again this morning to do that. So I have to go back and open it at the beginning. So I will reset that after we get done today. And a lot of times what I'll do is I'm writing to you and talking to you through my iPad, and then I'll go to my laptop here and look up homework questions and stuff like that. But let me, okay, so 8.4, number 8. We've got really slow, I guess everybody's in our neighborhood is at work right now, meaning they're on their computers.
And Pearson, especially in the evening,
Oh,
real slow.
no lie, right?
Yeah,
Oh my gosh.
They can all sleep in now, so they do all their work in the evening.
Yeah, I was like, yeah, and we got this real nice note from them that said, hey, you know, hope you're doing well. I'm like, hey, get your website going. All right, let me see if I can get into it on this one. One of my colleagues yesterday, he teaches a calculus class, and right before he was about to get on Zoom with them, his internet goes out, and he's like, you've got to be kidding me. And so he couldn't even, he ended up getting on his phone, at least he had audio with him, and to tell them, you know, hey, obviously we're not meeting. I'm almost there. I apologize for this. I should have had it up already. Okay. 8.4. Okay. Just with that description, I just definitely need to make sure I see the screen. Okay. Number 8. There we go. Okay, got him.
Good.
Yeah, you do have okay. And so we have, whoops, let me get my pen back. We have this right here. That O right there just means that's the center. What they've drawn here is the diameter that goes through the center all the way to the other side. And they have asked us to find the area here. And I'll just kind of like put some markings in there, all of this, right? Okay. So, well, the first thing is that when you look at this shape that they want us to find the area of, it's actually what we call a composition, because can you see that there's actually a triangle? And then there's also the secant of a circle. That's the secant of the circle. So the secant of the circle, we had a formula for him that kind of looks like a triangle, but it was 1/2 r squared theta, where theta was in radians. So that's what I'm going to use for this part there. Okay. It said that our circle has a radius of r. And so that's going to help us kind of match these two up. Because what we're going to do is we're going to find the areas of both of these and add them together. So this guy here with a radius of r, that's this side right here. And it's also this side right there. So those are both r's. And all they want to know now is, I think I've got all the info on there, don't I? I think so, yeah. Okay, and so this angle right here, this is our theta. Right here, okay, it's better on the actual picture here, but right here, this angle happens to be the supplement of theta. Here's theta in this little secant, and this angle right here is his supplement. So this is 180 minus theta. That's how big that angle is. So now what we can do is we can go back. In 8.4, they gave us a situation where if you have a side angle side triangle, side angle side, then the area formula will be 1/2, and I'm just going to pick letters here, AB, and then I would have the sign of the angle that's inclusive. So if you think about the triangle, what we're talking about is if you know these two sides, you better know this angle in between them. And we do have that situation up here. I have an R. That could be played as the role of B. I have an R here. That's like the role of A. And then this must be the angle C that they're talking about. So this area of the triangle version is going to be 1/2 R times the sine of 180 minus theta. And then we have something like, what is that? 1/2 of r squared, or you can even put r squared over 2 if you want to. I don't know what it's going to be better to do just yet, so let me just kind of leave him hanging. And then the sine of 180 degrees minus theta. What do you know about the sine of theta and the sine of 180 minus theta?
They're positive.
Mm-hmm. And do you think that they're going to be the same value or different?
Different.
Let's try. Yeah, let's just how about let's just hypothesize this. Let's see. Let's say that you and I have the sine of 35 degrees. Oh, let's do something we know. My bad. How about the sine of 30 degrees? We know that one, don't we? So the sine of 30 different from sine of 180 minus 30 degrees. Are they the same or different?
Different.
So sine of 30, we want to know if that's the same as sine of 150. That's what we're asking ourselves. Sine of 30 is 1/2, isn't it?
Let me pull up my unit circle.
If you go back to either your calculator or if you look at the
All right, here it is.
unit circle. Is that right?
Yep.
At 30? Yeah.
Yep.
Yeah. And then if you go over to the sine, or if you go over to the angle of 150 degrees, because his reference is also 30, I believe that the sine of 150 is also 1/2, isn't it?
Yeah.
Okay. So what that tells me then is that this statement right here that we had to just put in here, the sine of the supplemental angle is actually the same as the sine of the angle itself. So this sine of 180 minus theta, we just proved that, and that's what I was trying to show you up in the first and second quadrants. The sine values are going to be the same as long as your supplemental angles of each other. So here's what we have for the triangle part. This is what we have for the secant of the circle. And what happens if you add those two together then? Let's see. We'd have 1/2 of r squared times the sine of theta, and then plus, right, 1/2 of r squared theta. And so what kind of, let's see, what's their answer want to be? Use integers or fractions for any numbers in the expressions. And so by saying that, then what that means is that we're going to have to make sure, yeah, in your little table or your tool palette, you have the theta already there, so you can select it. So let's see if he'll take our answer. Okay, so I'll put in 1/2. And then I think he's going to probably holler at me because he's going to want it simplified, but let's just see. If he does, I can show you how to simplify it. And we have what, the sine of theta. And then plus 1/2 again. To simplify this one, it's not hard. I just don't know that it would be that much better looking, and usually we simplify things to make them better looking, but we can definitely factor out a 1/2 r squared if we have to. R squared.
I just put it in with the r squared over 2 and it said it worked.
Oh, it did? Sweet.
Yeah.
Okay, awesome. Now, did you factor it out or you just left it as a?
No, I just did r squared over 2 times sine theta plus r squared over 2 times theta.
Cool. All right. And I put in 1/2 r squared, like what we wrote right here, and he accepted it also. So good.
Okay.
We know that he's understanding this also, if you want to write it that way for yourself. Okay. Like I said, most of the time we want you to simplify things, but this one really doesn't have a real reason to simplify, because here you have a sine of theta and here you just have a theta. So they're not going to do much together with each other. So in fact, it'd probably mess around with your head a little bit if you tried to. So yeah, good question though, y'all. This one here, like I said, sometimes when they give us pictures, they are what they call composite, or what's another word? Compounded pictures. And when you were little, like sometimes you would have something like here's the face of the house and here's the roof. Well, there's not one formula for this entire picture, so you had to come in here and say, well, I know this is a rectangle, I'll find his area. This is a triangle, I'll find his area, and then I'll add them together. You remember doing stuff like that? When you're little?
Yeah.
Yeah. Okay. What's neat about this, why did they even do this to us? Well, it's a neat thing to kind of bring back up the secant of a circle. But the main reason they're bringing this up is because when you do get into calculus, you will have some pictures that have their own formulas, absolutely. And then you'll have some that are compound pictures. And then you start learning about integration when the area underneath your curve is not anything that's recognizable. And so that's when we learn how to integrate. And then that'll give you the area of whatever your figure is then. All right, great question though. Anything else?
Not that I can think of.
Okay. Number 9 is the same kind of deal. I think this one will be a lot easier for you. just simply because a home plate is, even though it's a irregular pentagon is what we call it, it's actually a triangle and a rectangle together. So you'll split it, do your own thing with them, and then come back. Okay. So what I saw was in there, I need to, one of the questions I need to find the answer to is, do we have a time limit on the quiz? So that's one thing I need to find out, and I'll send you an announcement. So is quiz timed? For some reason, I didn't think it was. I think it's just left open until you finish it. And then again, like I said, I'll put up there where you can upload your work, which is optional. And then the second thing that you'll need to be, the first thing I would do is I'd work on the little lab, because the lab's going to help you prepare for the quiz. Okay. So, sorry about that. So, any other questions that you got or concerns, or we really don't want you to have a actual assignment that's due on this weekend. We're trying to make sure there's not what she told us was no major assignments, nothing that you would not have had them do normally with the holiday coming up. And so, like I said, since we're not together, I can have things due on a Tuesday instead of a Monday easily now. So, but I will send you an announcement about this, whether or not the quiz is timed or not. And actually, you know what? Shoot, hold on. Let me get in here as a instructor now that I'm here, and I can tell you that right now. I forgot I was in here. Yeah, some people have been putting their test in my math lab, and oh my gosh, it has crashed like crazy. I feel so sorry for them. Let me come in here and see. And this will be, I believe, the last quiz that we have. We do have 4 tests. Originally, we did have 4 quizzes, but because of the extra week of spring break that we had, it kind of caused a problem. Let me see. I don't see a time limit at all. So it's going to open up on, it opens up, well, what is today, the 8th? It opens up this morning. It's already open. Good. You can see it that way. And it'll close on the 14th. Now, the reason why the gap is so huge is because of the weekend being Easter. So I wanted to make sure that you didn't have to actually work it during the weekend, but it is open right now. So some of you may be ready. And if you are, go ahead and take it. I mean, get it out of the way so you don't have to worry about it. And then you can just do the lab instead, or vice versa. Go ahead and get the lab out of the way and wait till Monday or Tuesday of next week and work on the quiz. It is a one-stop shop kind of thing. When you start working on that quiz, you need to finish it. And I will, let me see, I think I need to, I'll go into Canvas and I'll open it up for you to upload your work like you've been doing in the past. Okay. For those of you who got here a little bit after I started, there's been so many problems with Stream and the links I've been doing from Zoom over into Stream into Canvas. So now I will go and upload those between now and probably Friday onto YouTube. I do have a channel there, so I'll just upload those and I'll try to organize them so that they're done by date. And then that way you can run through them as you need to. And so from now on, that's what I'll do. And I will put on Canvas what the links are. So you can go straight to that one video instead of having to go through the entire channel of videos. I'll let you go straight to it. Okay. Can you think of anything else that I can do or help you with?
No, not really.
Not yet, anyway.
Is there going to be a review for test 3 on my math lab?
Yeah, there's one.
Yeah, I probably will still keep it there. That way you can definitely, I haven't looked at it. So if there is one there, there probably is one there from the past. I'll be honest with you, I can't even get myself into test mode yet with everything else that needs to be covered before we get there. But let me see. Yeah, it does say there is a test review here, but it was from the fall. It probably is a good one to look over. That's fine. But I will make a new one like I did last time. Okay.
Sounds good.
And remember, this test will be over because what we're doing is we're putting 2 very short chapters together for this test. So we're going to have chapter 8 stuff again. So what you're just about to quiz on, hush, shh, and then we will also put in there chapter 12. Chapter 12 is about sequences. Some of you had those in college algebra. If you didn't, again, you're kind of in a good spot right now. I mean, other people who have taken this class probably are envious. I know you won't believe that at this point, but I can't stop you from looking at formulas. And in chapter 12, there are quite a few formulas. In fact, I think there are five formulas for sure. You're coming out of law of cosines, law of sines, the area formulas, and also SOHCAHTOA and Pythagorean theorem. So you can imagine all the different theorems or formulas you have on this next test. I will tell you this though, they have requested us to use a lockdown browser. And so I'm probably going to use Respondus. Let me play with it just a little bit. The other one that the school has just gone into contract with is HonorLock, but I believe it requires a webcam. So I'm not going to require you to have a webcam. We're going to do this with, I hope that you'll always, you know, have the highest integrity of yourself, if nothing else, as you perform on your test. And it's kind of cool by putting the test on Canvas. Like I said, I can use a lockdown browser there, but I can also, even on your last test, I was able to go in and look at how much time you were spending on a problem where you weren't active, when you worked on another problem, when you weren't active. And so I did look through those to see if there's any huge gaps there. I don't see any, so I was kind of happy about that part. And I think by limiting the test, do you think a 2-hour limit still needs to be there?
I prefer no limit at all, but if you insist.
Well, we're limited in the class, so we don't have really a choice. But I picked 2 hours because we're almost a 2-hour class when we take a test. But my colleagues have indicated that 1 hour and 30 minutes is more than reasonable. And I don't know that that's really that reasonable. I'll be honest with you. I think keeping it at a 2-hour limit would be fine, and having you upload your work within the next 20 minutes after you submit the test. If you feel like that will work again, then I'll just kind of keep it that way.
I think 2 hours is good because you don't have to really rush that much.
Yeah, I don't want you to have to rush.
Yeah.
Right, I don't want you to have to rush. And one thing that'll help also, I know on my end, will be when you do this next test, if you will, and you have, I put it so that you can go through the test and work whatever problem you want, instead of saying you have to work number 1 and you can't move until you do. So I've given you the flexibility to kind of move through the test like as if we were in class. But if you'll do me a huge favor, if you go from problem 1 to problem 4, then either do it on separate pages, okay? Or whenever you start doing your work, leave space for problem number 2 and problem number 3. Do something so that the order will stay there for me. And one thing that was suggested for us to pass on to you guys was there's an app that you can get on your phone for free. Genius Scan is what it's called. Genius Scan. And what it allows you to do is you get to load in as many pages as it is, but it becomes one document instead of having to do a JPEG for every single one of the problems. So I'd like to offer that to you too, if you if you wanted to find a scanning process. Most of the teachers are using that one now. I'll say this, whichever is easiest for you, that's cool. But I used it the other day to upload some stuff. I had to send some paperwork to a doctor, and I was like, oh, I'll just use Genius Scan for them. And so it was pretty easy to do. All right, anything else?
Nope. I'm good.
Cool.
Yeah, I'm seeing the app right now. I guess I'll download it real quick and see how it works.
Yeah, and it downloads pretty fast too. I mean, it's not anything super significant at all, but it does the job. So I like that it takes all the pages at once to make a document.
Yeah,
so
that's
you
something I
still
messed up
yeah, you
last
still
time.
take the pictures like you normally would, but as you scan one page, then you just add another page, and you just add another page, and you just tell it you want it to be one document. So believe me, if I can figure it out, you can. All righty. The other thing too that we've already told you pretty much that we do know for sure that summer 1 and summer 3 are going online. We'll be converting those over. Right now, when you look at them, it doesn't say they're online, but they will be converted. Also, I noticed that I think you're going to be able to see fall schedule if you haven't already. I looked on Canvas and I saw it, so I don't know if it's just because I'm in the teacher mode, or has anybody looked to see if fall mode, if you're even gonna, are you, any of you coming back for fall?
I'm coming back.
I know a couple people for sure are not going to be, because it's time for them to go to the 4-year. Okay, well, and just FYI, it should be coming out pretty soon. Okay, yeah, Lena, I know you're one of mine for sure that's not coming back. So just FYI, so if you need to take a summer class, it's already out there. We're already, like my classes are easily halfway full, if not on the way to being full. And then, but everything will be online in the summer. All right, great. Well then, if you have any questions, feel free to email me, okay? If you're on a question like we were just a second ago on my math lab, just email me from there, and that way I have the problem that I can get to super fast. And otherwise, we've answered the question about is the quiz timed, and no, it's not. And I think that's all I have for you right now.
All right. Thank you. Have a good day.
You bet. Hey, y'all have a good
day.
Easter, good weekend as much as you can. And please, again, stay safe, stay well, wash your hands. Okay?
All right.
All right. All right.
Bye.
See y'all later.
See you later.